For more information on tutoring or how to support Moof University and the production of more videos, please visit moofuniversity.com. Thank you and enjoy. So next up is beta decay, specifically beta minus decay. Okay. I put a little note here. There are 3 types of beta decay, which I've actually mentioned in the intro. Beta minus decay, which is what this video is about, and then positron emission or beta plus emission, and electron capture. They're all classified under beta decay, but whenever someone or a practice problem or a textbook mentions just beta decay, they're usually talking about this one, beta minus decay. All right. So a beta particle is represented like this: mass number of 0 and a z of -1 with little beta, and sometimes it has the beta minus. And what it is, it's just an electron. Okay, so it can be represented like this, with a -1 down here, 0 up top, -1 down here with a 0 up top with an E or an E minus. Okay. So I'm going to use this one. Okay. That's the one I like to use. I like to use the one with the negative charge here. First of all, I like to put the beta because it's beta decay. It reminds me that it's beta decay. Also, the negative up there helps me remember that it's beta minus decay. It's just another reminder. A beta minus particle is also called a negatron. And you might think, isn't that kind of the opposite of a positron? That actually is the case. They are antiparticles of each other. We'll talk about that a little bit more in positron emission. We won't go into details. We'll just mention it again. Okay. So let's do an example. We have carbon 14 here as the parent. We have the A equal to 14, Z equal to 6. The N is thus equal to 14 minus 6, which will be 8. Okay, it's kind of an ugly 8. Let's try that again. That's a little bit better. Okay, so when this thing emits a beta particle, the A up here is 0, right? And the Z down here is -1. So what goes in for the daughter? If the A's on both sides, left and right, need to be exactly the same, or the total A and total Z's need to be the same on both sides. So if the A here is already 0 and the overall right side needs to be 14, then it remains 14. And if it was 6 initially, and now I've got this -1 here, something needs to go here. Well, I'll put a 7, because 7 minus 1 will equal 6. So now what's the identity of this daughter? It's going to be nitrogen. If you look on again, just the periodic table, you look for an atomic number of 7, you find nitrogen. Okay. So let's find the N's here. What is the N here? Here there are no N's because they would contribute to the mass number, so there's none there. Right here there's 14 minus 7, so there's 7 neutrons there. Okay. So what happened to all these values? Here the A stays the same. The A stays the same. What happens to the Z? We see that the Z goes from 6 to 7, so the Z increases by 1. What happens to the N? The N decreases by 1. Okay, so what happened here? It's kind of weird. Okay, well, let's think about what's going on, or why beta minus decay actually occurs. Beta minus decay occurs when there are too many neutrons in the nucleus. Too many neutrons in the nucleus. Too many neutrons. So what happens is a neutron is converted into a proton and an electron, which the electron is actually the beta particle that's emitted. So here I wrote that here as a neutron being converted into a proton plus an electron. Okay. So this neutron is decreased by 1 here, gets turned into this proton as well as an electron, right? And that electron is that beta particle out here that is emitted. Okay, so you can actually write these as 1, 0 here, 1, 1 here, and 0, -1 for those, right? Neutron has a mass number of 1, no protons, right? Or is an atomic number of 0. Proton, Z of 1, A of 1. Electron, we just saw with the beta particle, that is the beta particle there, right? This is this, right? So this occurs in beta minus decay, because beta minus decay occurs when there are too many neutrons. So the way that is solved is that neutron is converted into a proton and an electron. The proton remains in the daughter, right, to give that new element, and the electron is the beta particle that flies out of this nucleus. Okay, so this electron is not an electron from outside of the nucleus. This is a result of the conversion of a neutron into a proton electron. This electron will just fly out of the nucleus. Okay, so that's pretty much beta minus decay. Now, the general form is shown like this, based on this what I wrote here in green. The A stays the same, and the Z actually increases by 1. So it's shown like this. Okay, there we go. There's the general form with the little cloudy box thingy around it. And that wraps up this video. I hope that was helpful. Thank you for watching. If you found that video helpful, don't forget to like, comment, subscribe, and share with friends. Thank you, and happy studying.